Hi guys, it's been a while, but I'm back to making videos, so let's jump in. Today we'll talk about immutable records and more specifically how to copy them with changing some of the data. So the context is that we use immutable records or data structures, but we still would like to have an easy way to change them somehow, or not change but copy them with while changing some of the fields, because it can get quite tedious if you have a record like this with many fields, more than a few, and you need to copy them all, changing only one. So we'll see how we can make generic function that will does it for us. So let's start with TypeScript, then we go to a Java solution. So what we have here, we have a user record or data structure. It has a few immutable fields. We have one method, which is in a while why it's important. And we have another user role record just to illustrate nested objects and also collections. Because there will be one caveat with that. And then we have an example of a few changed users, but maybe let's first go to the method that I have prepared, which is records copy. So it's just one function actually. What it does, it takes a source, which is any object, as you can see, and fields to replace. And the basic idea is that, as you can see here, that we have user and we would like to change one or more of its fields. So here you just specify that. But to do that, we need to do some validations. So here we verify that fields that you want to replace, they exist. And how we do that, we basically iterate over fields to replace. If they are not in the source, we throw an exception. Then we also go over, we take a field from the source object and we compare the types by checking the constructor name. That's, I think, the best way you can do this in TypeScript/JavaScript. And if we pass this verification, we just use object destructuring operator, which will copy all of the fields of the source here. Same with to replace fields, and if we have in the to replace fields variable fields of the same key, same name as we have in the source, they will be replaced because to replace fields is last in the order. And here we also have set prototype of this result to the source. And let's actually show why it's important. So I have run it, but let's do this again. So to give you additional context, all of the code will be in the Git repository. Of course, link is in the description, but basically I have basic TypeScript project with some definitely actual dependencies for tests and TypeScript, and I have my small script that will just compile TypeScripts and run our experiments file. So let's do this. So npm run build run experiments, I think. Yeah, and here we have results. So we have a user, we have changed users, changed user 1, changed user 2, and we are printing them. So as you can see, the user is of type user, the type user class. The same is for changed user 1 and 2, which are the result of our method. And they have type, as you can see, the same type as source user. Same if we print the constructors and changed user one is able to use this method. And if we comment that, we don't set a prototype, we'll see that these users, they are of type object, the object literal, and they will not have access to that method. That's first consequence. And the other is that they will be of different type. So let's actually see. Yeah, this will throw an exception. Yeah, because changed user, it doesn't have access to this method. And if we go here, its constructor is just a function of type object. So that's why we need to have that thing. And what are the limitations, guys? So as you can see, this is a shallow copy, so we only copy fields. So you need to make sure that all of the fields in your records, data structures, they're immutable, or you are just okay with that they are mutable. So as an example, we can see that changed user 2. Let's actually run it. It doesn't have any roles here. So, or maybe the better example will be here. So changed user 1, it has a role of admin, but if we and it's the same as in user, because this user, because it's source. But if we do user roles push and do something like that, so we'll basically mutate roles of first user. So something, I don't know, some moderator. The user roles, the roles will change in this user and in this user because they share that. So here you have, we have added the moderator to this user, and as a result also the changed user first has moderator role, even though we did it here, so after copying the user. So you need to be aware of that. To do something like copying this in a nested way, I think it's overcomplicated for the practical purposes, to be honest. And one other thing is that we don't verify types of generics. So we have list of user roles here. We have user role type here, but we still can do something silly like that, and it will all pass. And in runtime we'll have change user 2 with roles of number and string. So just keep that in mind. This is the limitations that we are willing to accept. Yeah, and let's head to Java example. I have implemented the same thing. Obviously it looks quite different. So here we have records, and interestingly enough, as you can see, you can define it in a quite neat, lean way, because we have this record keyword starting from Java 17, and basically these fields are read only. We have first role method, the same as in TypeScript, and user role. And we have records copy. It's a static method because we need to always have a class in Java. And here we are using map as to replace fields, because Java is typed. TypeScript is also typed, but this it has more loose type system, let's say. And here, similarly to TypeScript, we first take, or maybe a little differently, first we have new record fields method. We take source and to replace fields, and we construct a map, a linked hash map. It preserves the order of insertion. We need that to call a constructor, which is in a minute. And here record type is a class that we are copying. We are having it from this first argument, and we have a method in Java reflection package to basically get record components, and it returns the description of these fields that we have declared in the record header, which is primary constructor, I guess. And we have we take field name and field type for every of these guys. We take to replace fields map. We check whether we have something to replace that there. If not, we are taking the old value. This is how we are doing that, and this actually will call a method like that. So let's see that we are copying user ID. So we have this accessor basically. It's like getter, but it is enveloped in a method. Yeah. And if we do have to replace field as non-null, we check we are taking type, or basically we are checking the type of the field that we have found to be changed. We are comparing whether this field is of the same type as required here. If not, we are throwing exception, and we actually did the same here. Records copy error here. Here we have just copy exception. Actually, I should change that to our custom exception. What's wrong? Yeah, we are going. Oh no, okay. We can have runtime exception here, guys, because we are having try catch. We are catching any exception and wrapping it in our own copy exception. Okay, and then if types are valid, I mean the same, we are putting this to record fields. And this record field is a map, so in the end it basically will be ID something, name something, image something, created at something, role something, and so forth. And then we have this map. We validate if to replace fields exists, because we were iterating over required fields, not over the fields that we gave. So basically we wanted to see whether somebody gave something and to replace fields that doesn't exist in the record as a validation. If this passes, we need to find primary constructor of this record. We didn't have this problem in TypeScript because we can copy object literally. In Java, you need to call constructor using reflection. So how we are doing that? We are again taking record components, and we are looking for a constructor that has them in the same order. And if you declare records like that, this is the only way to declare record in Java. It always has this constructor with these arguments in this order with these types. So we have a guarantee to find it, and once we have it, we are changing record fields map to array, its values so that we can call the constructor. That's basically it. So let's run it. Yeah, and similarly as in TypeScript, we have users, user1, change users, type, we have like that. This is fully qualified class name from here, it's the same. And then we are able to call the first role method, and same as in TypeScript. Obviously, the roles list is mutable. I mean, in that case, it is not, because list of will throw an exception on us. So let's do, for example, let's try to add new user role here, like that. and it will throw exception because list of is immutable, right? So supported operation exception. But let's say that we will make it as new array list. Actually, let's wrap it in new array list, and we will have the same problem as in TypeScript. So user1, it has roles of admin and moderator here, and same for changed user1, even though we did it here. So same, be careful with that, and same we have we can do, I guess, that or not. No, we don't, because here we have type checking in Java, but give me a sec. If you do if we override it here, so roles, and here we can do something silly like that, and we are not able, I mean, we are able with complex code, we would be able with complex code to check it through reflection, but I don't find it worth doing, to be honest. And here you can see you have roles of different type, and if you would do something like that, let's see, first row, changed user, first row, get or row, it will compile, but it will throw an exception in the runtime. Yeah, so be aware of these limitations, but I don't think it's an issue because you still should test your code. So you will be fine if you test your code. And yeah, something else. I think that's basically it, guys. So to wrap up, we have created generic copy method to copy immutable records, both in TypeScript and Java, so you can change your records, not mutate but copy with change field easily. So if you like the video, subscribe, and see you next time. See ya.